All right, so today we're in section 9.1, finding square roots. Finding square roots. All right, everybody remember what a square root is? A symbol. We can air draw it. We can draw it in the air with our finger, right? That's what my daughter's really into right now. She's like, Mom, I can draw a 5. And then she'll, anyway. You know what I'm talking about, right? The square root sign? Okay, well, there it is. There it is, important info. People watching this video are probably like, man, she's crazy. I know. Nothing new to me.
So it's pretty much the complete opposite of an exponent.
It is, and that's exactly what I was about to say. A square root sign is the exact opposite of squaring that number, okay? And that's what we see on the first point, that squaring a number and finding the square root are inverse operations. We see that 2 squared equals 4, and the square root of 4, which was the answer, the square root of 4, goes back to a 2, and we see that they are inverse operations. All right, we also need to know that a perfect square has a factor that can be multiplied by itself to equal that number. We're going to talk more about perfect squares in just a second. All right, make sure you leave like 2 lines in between that the second and third point, because we're about to write out all of our perfect squares. All right, and then the radical, all right, that's what I was just drawing, okay, kind of air drawing. But the radical sign is positive unless there is a negative or a positive and negative, we'll talk about that in a minute, sign in front of it, okay? So if it's just the radical is positive. So it determines now, okay, yeah, my answer is going to be positive. So the very first perfect square when I start at 0 is 1. Because 1 times 1 is 1. Okay, so that's my first perfect square. All right, you do need to have these memorized. All right. The next perfect square, we're just going to keep going up the number chain, all right? So we start at 1. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 3 times 3, not 3 to the third, okay? 4 times 4 is 16. Say them with me, guys. 5 times 5? 25. 6 times 6? 36. 7 times 7? What about my 8s? What about my 8s? 64. What about my 9s? 10s? 11s? 121. 12s? 144. 13s? Anybody know? 169. 14s? 198. And 15s, 225. All right? So we just listed 15 numbers. All right? What was the smallest number? 1. What was the largest number? 225. So between 1 and 225, that's 225 numbers. Only 15 of them are perfect squares. Meaning only 15 numbers out of 225 numbers can be evenly taken the square root of. So how many numbers does that leave that will not be even square roots? 210. 210. If there's 225 numbers and only 15 of them have even square roots, that means 210 numbers will not have an even square root. So which one do you think is the majority? You think you're often going to see an even square root? No. Okay? But those numbers that do have the even square root, those you can memorize. Those you can recognize and pick out of a crowd of a whole lot of numbers, right? Because there's only 15 of them. All right? Now, could I keep going higher and higher and higher and higher to infinity? Absolutely. But for the sake of what we're learning in chapter 9, we're going to focus on the bottom 15, okay? Because that's something that is feasible for you to memorize. All right, so we're going to recite these, all right? And we'll start right now, okay? So let's say them out loud. Let's go 1, just read them with me. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 124, 169, 198, 225. All right? And the more we read those, the easier it's going to be for you to recognize them. Now, again, you're going to see this in examples 2 and 3. That radical sign, when it's in the original problem, determines the sign of your answer. So that's really important. All right, let's look at example 1 now. You need to write down these 4 numbers: 49, 100, 121, and 36. All right? And what do you see about the title of your example? What do you see? What did I just highlight?
Perfect square.
These are perfect squares. We just listed them. So we know that you can evenly take the square root of all of these numbers. This is a section on your quiz. It's a section on your homework. It's a section on your test. So if you have your perfect squares memorized, this should be a 100% accurate section, okay? Because this is one that you could, like I said, just memorize, know the answer, and it's the same answer for each square root every time. Guys, so what number can be multiplied by itself to equal 49, Caleb? 7 times 7 equals 49. But negative 7 times negative 7 is also 49. And because there's no radical in my original problem, as long as the final answer is 49, both signs can actually be the square root. Negative 7 times negative 7 is positive 49. So I would say anytime, again, no radical, it just says find the square, and maybe you caught on to this, it says square roots, plural. Each whole number actually has 2 square roots, positive and negative 7. Without the positive negative sign, it's actually not correct. All right, so I've had kids ask me, well, what if I say positive 7 and then I say negative 7, I write it twice? Technically, that's correct, okay? But this is the way that we want to write it, with the positive negative symbol, because you're going to see it all through chapter 9. All right, so that positive negative symbol means that my answer is both positive and negative. You with me? You do not have to show this part over here. I'm just showing you why the answer is both, okay? You don't have to show that part. So based on what we just said for 49, what do you think your answer is for 100? What do you think? Positive and negative 10. Okay? All right, answer the other 2. All right, 121, what is it? Positive, negative 11. If you only say 11, that is not correct. Okay, it's got to be both. Because negative 11 times negative 11 is also 121. All right, what about 36? Positive, negative 6. All right, you see why I said this should be a 100% section? Everybody gets these right? Because there's only so many perfect squares to choose from. Okay, you just have to remember your positive, negative. That's it. All right, example 2. Go ahead and write down these 4 problems. Skip a line or 2 in between each one. Okay, go ahead and write down these 4. So the square root of 25, again, the radical is positive unless there's a sign in front of it. So the square root of 25 is 5. And that's just my answer. Okay? But now look down to the next one, the negative square root of 49. Okay? So what number times itself equals 49? 7. And because that negative is out front, it's going to be negative 7. Negative 7. Okay? So just watch for the sign that's in front of the radical. All right? So what do you notice that's in front of the 16? It's both. So what's the square root of 16?
Positive negative 4.
And then you, would say positive negative 4 because of the sign that's in front of the radical. So you're just bringing that over into your answer. All right? Go ahead and answer the last one now. Just go ahead and answer the last one. Caleb?
It is
Negative 9. You agree with him? Okay. All right, guys. Good job. All right, so we're through example 2. We just have one more example. Now, there are 6 examples in 9.1. We're doing the first 3 today, and we'll do the last 3 on Tuesday. Okay? All right, so here's example 3. All right, go ahead and write down each of these. Obviously, you probably notice the obvious with each of these numbers. They all have something in common, and what is that? They're all fractions, okay? So we're going to talk about taking the square roots of fractions. The good news with this lesson is the numerator and denominator will both be a perfect square in this lesson. Within this unit, we're going to see fractions that are not perfect squares, and we'll talk more about that next week. But for today's lesson, all of these fractions will be perfect squares. All right, so go ahead and write these down. Just skip a line or two in between. So when we take the square root of a fraction, what we can actually do is take the square root of the numerator and denominator. It's important to recognize that you can split it. All right, not necessarily for this lesson, but what if one side of the fraction you could take the square root, but the other side you couldn't? All right, so in a couple sections from now, next week, we're going to see that. Now, for this week, you can take the square root of the top and bottom. Okay, but we're going to go ahead and show that when the square root is over the whole fraction, I'm actually taking the square root of both numbers. So what is the square root of 9? 3. And what is the square root of 16? 4. So that's my answer. Okay, that's my answer. So you just take the square root of each number, and then you got to pay attention to this sign in front of the radical. Okay, so that's got to be in your answer too. So take the square root of numerator and denominator, make sure it's reduced all the way, and then that will be your answer. So I want you to try this second one. Make sure it's reduced all the way after you take the square root. And don't forget the positive negative in your answer. All right, so the square root of 36 is what? 6. Okay, don't forget, you don't necessarily have, you really don't even have to write this step at all. All right, but just don't forget about that positive negative. But this is not your final answer because 6 over 9 can be reduced. 2/3. 2/3. Make sure it's reduced all the way. Okay, now that's not going to happen very often, but you just want to check that. All right, look at the top. Okay, guys. Look at the top right one. What is the square root of 1? What's the square root of 100?
10.
And don't forget to bring over your negative. Okay? Negative 1 over 10. Who got that? Negative 1 over 10? Okay. What about the last one? Square root of 4?
2.
Square root of 25? 5. Positive negative 2 over 5. Okay, now there's going to be one more thing, not on your homework tonight, but on your classwork worksheet tomorrow that I need to cover with you guys before we're done. 2 more problems. If I asked you to compare these 2 numbers, basically, would a greater than sign go in the blank, a less than sign, or an equal to sign? Well, I can't just say, oh, well, 36 is bigger, so greater than. Okay, I need to take the square root. What is the square root of 36? So is 6 greater than 4, less than 4, equal to? So then you would say greater than. Okay, so you have 2 questions on your worksheet tomorrow. Just take the square root and then compare them. Okay, all right, so what about this next one? The square root of 49 and 7. The square root of 49 and 7. What's the square root of 49? 7. So 7 equals 7. All right? And that's basically how you would do it. And that's it for part 1 of section 9.1.